So section 7, inspection, data evaluation, analysis and recording. Section 7 of API 570 code is more focused on how you are going to identify and how you are going to understand whatever data that you have received after the inspection has been done. So section 5 was inspection. Section 6 was interval frequency and extent of examination. So we understood that what kind of inspection that we can do. We also understood that the time required for examination will be different based on how what kind of risk the part is associated with. What would be the consequence of failure? What would be the probability of the failure? If risk-based inspection approach is not used, then what should be the interval for different classes of piping systems? We have already seen in section 6. Now we'll move ahead towards section 7 to make sense of whatever data that we are receiving and how can we understand what is remaining life assessment, how much corrosion is happening in a particular circuit or a particular piping system. So first, always going to be corrosion rate determination. Corrosion rate determination general, the owner user may either use a point-to-point analysis method or some statistical analysis method or a combination of both to determine the long-term and the short-term corrosion rate. So in point-to-point method, we have the formula for long-term as well as short-term corrosion rate. The long-term corrosion rate is T initial minus T actual, the time in years between the T initial and T actual. We'll understand this by a simple example, but first we'll need to understand that there is some formula for a long-term corrosion rate and for a short-term corrosion rate. A short-term corrosion rate for an individual CML can be calculated by the following formula. The short-term corrosion rate is T previous minus T actual, the time in years between T previous and T actual. Okay, so we'll talk about this later on with the help of some example. So long-term and short-term corrosion rate should be compared to see which results in the shortest remaining life. As part of data assessment, an authorized inspector in consultance with corrosion specialist shall select corrosion rate that best reflects the current process. So depending on if everything is going as expected, then the long-term and the short-term corrosion rates are generally going to be similar. If your long-term corrosion rate and short-term corrosion rate has a great amount of deviation, this means that some process variability is there which is increasing or decreasing the corrosion rate from the historical perspective. Okay. Now remaining life calculations, the remaining life calculation will be T actual minus T required divided by the corrosion rates in mm or mils per year. Okay. Next, so just let's see how these are seen with some help of an example. Okay, so let's imagine we have an example like this. So I have a piping system where the thickness of this piping system is 50 mm. The minimum thickness required for it to sustain the pressure is 20 mm. Now a very conservative estimate has been taken, but just to understand, the minimum thickness required is 20 mm and we are making a pipe of 50 mm, so 30 mm corrosion allowance is there. Let's imagine it's a class 1 pipe. We already know that in class 1, thickness measurement will be done once in a 5 years and external visual inspection also would be done once in a 5 years. So in this case, after 5 years when we do inspection, the thickness I received is, let's imagine, 43 mm. The next 5 years, the thickness was found to be 36. In the next 5 years, the thickness was found to be, let's imagine, 28. Okay. In the next 5 years, something else would happen. Okay. So in this case, let's see what is the long-term corrosion rate. So the long-term corrosion is T original minus T actual. So T original is 50 mm, T actual is 28 mm, and divided by how many years have been passed. So in this case, 15 years has been passed. Okay, so when we solve this, the answer that we are going to receive is approximately uh, So the answer we are receiving for a long-term corrosion rate is 1.466. So this much corrosion is happening per year. This is a long-term corrosion rate. Let's find out what is the short-term corrosion rate. So the short-term corrosion rate is between two consecutive intervals. So let's see the short-term corrosion between these two intervals is how much. So in this short-term corrosion, the previous inspection results were 36 mm, and the inspection that is done latest, you have 28 mm divided by 5 years that has passed between them. So 36 minus 28 divided by 5 will give you 1.6 mm per year. Okay, so the long-term corrosion rate was not as extensive. Short-term corrosion rate is now been increased. Now we can do some additional assessment that what led to the short-term corrosion rate to increase significantly. Okay, now we can also find remaining life. Now let's prefer that the remaining life we are assessing with the help of a long-term corrosion rate. So this will give me the remaining life, the life that is required for the piping, the minimum thickness that is required is 20 mm. So now the thickness of the pipe is 28, minimum thickness required is 20, and 1.466 long-term corrosion rate is happening. So the answer for this is going to be 8 divided by 1.466, which is going to be 5.45 years. Okay, so this much life is remaining if the whatever the corrosion happens, if it coincides with long-term corrosion rate, then the pipe is going to be going on for 5.45 years. Obviously, if I have done this calculation with short-term corrosion rate, the remaining life would be much shorter because the corrosion rate was much higher than the long-term corrosion rate. So this is what it means. What is long-term corrosion, what is short-term corrosion, and what is remaining life for your piping system, the formulas that were given in API 570. Now let's look at something else that is also mentioned there. So we have already seen what is remaining life calculations. So let's go on. Newly installed piping systems or changes in service. For new piping systems and piping systems for which the service conditions have been changed, following method shall be employed to determine the probable rate of corrosion from which the remaining wall thickness at the time of next inspection can be estimated. A corrosion rate for the piping circuit may be calculated from the data collected by the owner, user of the piping system of the similar material comparable to the service or comparable to the operating condition. Let's imagine I have two pipes. Okay, one pipe, sorry, I have two pipes. Both of the pipes are made with same material. They are same diameter. They are also in the same service. The liquid that is flowing in one also is the liquid flowing in the other. Other conditions are also same. Pressure rating is same. Temperature requirement is same. Service conditions are same. So it can be a informed decision that if the one pipe is subjected to some kind of damage mechanism, there is a high likelihood that the second pipe, which is under same condition, same operating fluids, same material of construction, will also be having the same problem. Okay, so the corrosion rate can be determined. This is known as similar service concept. So in similar service concept, if two equipments are in similar services, the damage mechanisms would also be similar. Okay, we have a reason to believe that the damage mechanism would be similar. It might not always be the case, but we can think like this. Okay. If the data for the same or similar services are not available, the corrosion rate for the piping circuit may be estimated from the owner user experience or from the published data on the piping systems in comparable service. If probable corrosion rate cannot be determined by either methods listed in 7.3a, 7.3b, the thickness initial thickness measurement determination shall be made after no more than the 3 months of service. Okay, so if original data is not given, then once the part goes to service, in first 3 months we'll need to do assessment that what is the issues with the new piping that we have installed, and based on that we would be deciding the future inspection criteria for the same piping system. Now, existing and replacement piping, the corrosion rate shall be calculated by one of the methods that are laid down before. For repaired or in-kind piping, in-kind replacement piping, the corrosion rate shall be established based on the previous worst case measured at the replacement location or the circuit average. If the calculations indicate that an inaccurate rate of corrosion has been assumed, the rate to be used for the next inspection shall be adjusted to agree with the actual corrosion rate found. Next is maximum allowable working pressure. Now, maximum allowable working pressure for continued use of piping system shall be established using the applicable code. So, maximum allowable working pressure is the pressure that your piping system can sustain at its maximum condition. So, it's the maximum pressure that your piping should sustain in a running condition.